Section 3.5, Implicit Differentiation. The functions that we have met so far can be described by expressing one variable explicitly in terms of another variable. So for example, y is equal to the square root of x cubed plus 1, or y is equal to x times the sine of x. Or in general, y is equal to some function f of x. Now some functions, however, are defined implicitly by a relation between x and y, such as, for example, the first one, x squared plus y squared equals 25. Or we can say we have x cubed plus y cubed equals 6xy. Now in some cases, it is possible to solve such an equation for y as an explicit function or several functions of x. So for instance, if we looked at equation number 1, if we wanted to solve for y, we would subtract x squared to both sides and then take the square root of both sides, which then would give us y is equal to plus or minus the square root of 25 minus x squared. So two of the functions determined by the implicit equation 1 are f of x is equal to the positive form of the square root of 25 minus x squared, and g of x is equal to the negative square root of 25 minus x squared. Now the graphs of f and g are the upper and lower semicircles of the circle x squared plus y squared equals 25. So here is the original function. This is the positive version, so that is the upper part of the circle. And then this is the negative version of it, which is the lower part of the circle. Okay, now if we take a look at equation number 2, which is x cubed plus y cubed equals 6xy. Now, it's not easy to solve equation 2 for y explicitly as a function of x by hand. Now, a computer algebra system has no trouble, but the expressions it obtains are very complicated. Nonetheless, equation 2 is the equation of a curve called the Folium of Descartes, and that is shown down here on the left in figure 2 here. Okay, and it implicitly defines y as several functions of x. Now the graphs of three such functions are shown here in figure 3. Here are the three functions defined by the Folium of Descartes. Now, when we say that f is a function defined implicitly by equation 2, we mean that the equation x cubed plus f of x cubed is equal to 6x times f of x. And that is true for all values of x in the domain of f. So what you can see here is that the y now is becoming f of x. So here you can see the graphs. Now if we go below, fortunately, we don't need to solve an equation for y in terms of x in order to find the derivative of y. Instead, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x, and then solving the resulting equation for y prime. In the examples and exercises of this section, it is always assumed that the given equation determines y implicitly as a differentiable function of x, so that the method of implicit differentiation can be applied.